This video is looking at Group 1 metals and is in C4 in the GCSE OCR spec. These are the first three Group 1 metals, also known as the alkali metals, that we need to look at. So lithium, sodium and potassium are the ones that you study in detail, and what you'll most likely be expected to do in your exam is to describe these three and then make predictions about the more reactive elements that follow. These are the three that we can safely use in school. So you can see lithium, sodium and potassium are all stored in oil. And this is because if you look carefully at their surface, you can see that it's not shiny like a regular metal. And that's because these are very reactive, so they react with the air. So lithium plus oxygen would give you lithium oxide. So the surface of these is actually a coating of lithium oxide. This is sodium oxide. This is potassium oxide. So we store them in oil. We can't store them in water because we'll see that's one of the main reactions that they do, and they react very violently with water. You can also see from this that lithium is floating in the oil. So lithium is the least dense of the metals, and it's less dense than oil, whereas sodium and potassium are more dense than oil because they are sunk. So let's have a look at this another way. So if I cut into a piece of sodium, you can see the inside is shiny, like we typically expect a metal. So you can see the sodium oxide on the outside. And this also tells us another thing. These metals are soft, which again is an unusual property for metals. We usually think of metals as hard. And the softness increases as we go this way. So potassium is very, very easy to cut, like cutting butter. But all of them can be cut easily with a knife. So this is the first of the metals. This is lithium reacting with water, and what you can see is it is fizzing. The technical word for fizzing is effervescence. So it's producing a gas, okay? And the gas that happens to be formed here is hydrogen, which we'll look at in a minute, because this behaves just like an acid and a metal. The acid in this case is the water, and obviously we have a metal, so we get a salt and we get hydrogen gas. You can also see the lithium hasn't changed shape. Now on the second one, you can see here, sodium has changed shape. It's become spherical, and that's because basically sodium has melted. So one of the other properties you should know is that the melting point of the group 1 metals decreases as you go down the group. So sodium has a lower melting point than lithium. So when this reaction happens, it is exothermic. It produces a lot of heat, and that heat causes the sodium to melt, and that's why it's in the spherical shape, as opposed to a lithium here, which you can see hasn't melted. You can also see in this case we've added to the solution universal indicator. So you can now see this purple colour starting. This is why they're called the alkali metals, because they form alkali compounds in solution. So this will be forming sodium hydroxide as the salt dissolved in this solution. And sodium hydroxide is an example of a base. And that's why it gives it as a purple alkali colour. If we look at the next one, this is potassium. So you can now see this reaction starts to look a lot more violent. So not only is it melted, but it's actually ignited and caught fire, and potassium burns with a lilac flame. Now this trend continues as we go down the group. So we have at the top of the group lithium, we then have sodium and potassium. Those are the three we've just looked at, but if I could keep going, we then have rubidium, we have cesium, and then right at the bottom we have francium, which we don't talk about because it's radioactive. But the reactivity of these elements increases as we go down the group. Now if we explain this in a really simple way, you can imagine lithium being a small atom, sodium and potassium getting larger, rubidium being larger still, cesium being by far the largest of the atoms. And so the distance between the nucleus and the electrons increases as we go down the group. So it's easier for the elements at the bottom of the group to lose their electron. That's what happens when all the group 1 metals react. In this case, the potassium is losing its outer electron because it has one electron in its outer shell. It loses that to form a potassium plus 1 ion. And it's easier to do that lower down the group because the attraction between the nucleus and the electrons is weaker. So as you go down the group, reactivity increases because the size of the atoms increase and the attraction to the outermost electrons decreases. It becomes easier to lose electrons. That's the key phrase. So we've just seen that potassium burns with a lilac flame, sodium burns with a red flame, and lithium burns with a red flame, and sodium burns with an orange flame. So you should also know these colours. If we have a look at the elements themselves and look at what they've got in common, because they're in group 1, you can see they all have 1 electron in their outer shell. So if we write their electron configurations, for lithium it'd be 2, 1, sodium is 2, 8, 1, and potassium is 2, 8, 8, 1. So they all have 1 electron in their outer shell, and when they react, they all lose that. So again, this looking at the periodic table, so this is the whole group: lithium, sodium, potassium, rubidium, and cesium. And what they like to do in exams is to ask you about trends as you go down the group. So what we're expected to know, just in summary, is we need to know the properties, which we've already looked at. We need to be able to describe these trends and patterns, and we need to know some equations. So let's just review what we've covered so far. So group 1 metals are all metals. They react vigorously with water and form alkali solutions. That's why we call them alkali metals. They also react very strongly with air, and that's why we store them under oil, as we saw here. All 3 metals float when added to water. So this is something we didn't mention, but it was obvious in the pictures. Each time the metal was floating, which means they're all less dense than water. Remember, the density decreases as you go down the group. They all produce hydrogen. They all fizz when they react. So in every case you produce hydrogen, and that pushes the metals around the surface of the water, and reactivity increases as you go down the group. This is a graph that shows the melting point of the metals decreasing as you go down the group. So like we said before, lithium keeps its shape, but it will dissolve. It will break up. If there's lithium hydroxide in the solution, it will break down. It won't ignite. Sodium forms a silvery ball. It does melt. We'll show any of them, if you add universal indicator, will show you the purple colour. But again, it doesn't ignite. Potassium is more reactive still, so it does ignite and explodes with a lilac flame. So this is our general equation for the group 1 metals. So this is the next most important bit. So any of the metals plus water will give you the metal hydroxide and hydrogen. So as an example, if we have lithium as a solid plus water, which is H2O, that will react and we will get the metal hydroxide. So we will get lithium hydroxide, so OH. That will be dissolved in the solution, so that will be aqueous, and then you will also get hydrogen as a gas produced. Now, last thing on this that's important is you have to balance it, and this is easy to balance. You put a 2 in front of all of the numbers, apart from the hydrogen, which has already got its limit. So once you've balanced this and you put a 2 in front of everything, nice and easy to remember, just 2, 2, 2. Now, the only other reaction we need to know about for the group 1 metals is, like I said, if they react with oxygen. So if the metal reacts with oxygen, oxygen is O2. And so what we will form in that case is lithium oxide. Okay, and so in order to balance this, we need to put a 2 there and a 4 there. So lithium plus oxygen gives you lithium oxide. If it was potassium, it'd be potassium plus oxygen gives you potassium oxide. And in the top reaction, if it was potassium, potassium plus water will give you potassium hydroxide and hydrogen. If they asked you about rubidium and cesium, which are obviously elements that are lower down the group, the reactions are identical. That's the point you've got to remember. The only difference is they're going to be even more reactive. They're very dangerous, very explosive. So cesium plus water would give you cesium hydroxide and hydrogen. The only other reaction that we need to know beyond that is just showing how the group 1 metals lose their electrons. So if I'd got, say, for example, lithium, it would lose 1 electron. It loses electron from its outer shell, and then it will form a lithium plus 1 ion. And all of the group 1 metals form plus 1 ions or cations. So they all form positive ions when they lose that 1 electron from their outer shell. So if I was looking on the periodic table, for example, and I could see lithium plus 1, I'll see lithium's numbers are 3 and 7. So that means that lithium has 3 protons, it has 4 neutrons, 7 take away 3, and a lithium ion, because it's lost 1 electron, would have 2 electrons. If it was a lithium atom and it hasn't lost an electron, it would be 3, same as the number of protons. So this is an example of a 6-mark question that you might have. So you can see here lithium, sodium, potassium, and as I discussed, they're going to ask you about rubidium. It's another one of the group 1 elements below potassium, and they're asking you to predict the reaction time. And obviously it will be more reactive, so the reaction time will be less. Name the products. So remember, it's always the same. So it's going to be rubidium hydroxide, just like it would be lithium hydroxide, sodium hydroxide, and potassium. And its products. So the other thing that you also get in each of these cases, you get a gas which burns with a pop, and that's hydrogen. And the balanced equation for that would be exactly the same as what we discussed here, but it would be Rb. So 2, 2, 2. Rubidium plus water gives you rubidium hydroxide and hydrogen, and that's how the question is structured. They could do the same thing with any of the group 1 metals, so for example they could do cesium.